All right. So section 4, we're just going to take a bunch of stuff that we've already gone over and put it all together. They're going to give us a polynomial in what's called standard form, typically. It's not factored. We're going to factor it using all the tools that we've learned so far for factoring, and then we're going to graph it using what we did yesterday and the day before. So let's try it. Off on the side, types of factoring. GCF. This is in the order you should try them. Start with GCF first. Does that make sense to everybody? Once you've done that, then check for difference of squares. There's going to be a ton. Almost every problem has a difference of squares in it. Trinomial factoring when A equals 1. That's the whole what multiplies to the C term and adds to the B term. Trinomial factoring when A is greater than 0. The idea being, okay, if I'm factoring something out and there's an A value, but it's a part of the factoring, kind of using guess and check, you can do that as well. And then we might even get a sum or difference of cubes from last unit. That one would be your last resort if nothing else works. There's actually one more. Let's go ahead and add this in on the bottom. I would do this one before a sum or difference of cubes, but they're exclusive. You won't be able to do both, so it doesn't really matter which way you check for them. If you have something that looks like x squared plus bx, bx plus c. So where you would normally do trinomial factoring, what multiplies to c but adds up to b. But instead of x squared and x, it's x to the 4th plus bx plus c, or sorry, bx squared. So essentially, you have more x's than you're used to. X to the 4th and x squared instead of x squared and just x. This will factor just fine as x squared and something, x squared and something, okay? I'll show you an example. It comes up on the first couple problems. And really what I should have done here, in between there, here, I'm going to redo this. If you already wrote it down, no worries, you can write it in between. But this factors into x and something, x and something. X to the 4th plus bx squared plus c would factor into the same things, except it would be x squared and something, x squared and something. It's an extension of the normal factoring that we've already done with trinomials. I will show you several examples. So let's try it. Look at number 1. First things first, check to see if there's a GCF. Is there anything that multiplies to make, or that anything that goes into x cubed and negative 25x? X, they both have an x. Does that make sense to everybody? Take that x out. Y equals x times x squared minus 25. And right there is our first difference of squares, right? X squared minus 5 squared. The hope is at this point, you're really good at factoring those difference of squares. If not, you're going to get really good today because we're going to do a ton of them. This is x squared. This is 5 squared. So this is going to factor into x plus 5, x minus 5. There is my factored form. This is what you would have gotten the last couple of days when you're graphing them. So now we're going to go from there and come up with our x-intercepts. So x-intercept here would be 0, right? That's the one that we often forget. Just an x by itself is an x-intercept of 0. This one would be a negative 5. This one would be a positive 5. I would also get a y-intercept normally, except does everybody see that this 0 right there is 0, 0? That would be my y-intercept already. If I plug in 0 to the equation, the whole thing becomes 0. So this is both an x-intercept and a y-intercept. The one nice thing of not having it factored to begin with is that it's easy to find the leading coefficient and the degree. This one's a leading coefficient of 1, degree of 3. odd positive. So high, high. Or sorry, no, low, high. Low, high. And then we graph it just like we've done before. So x-intercept at 0 and 1, 2, 3, 4, -5. 1, 2, 3, 4, +5. Starting low, up, down, back up. Does that make sense to everybody? We factor it and we graph it like we did before. Let's try number 2. This one is f times g of x, right? It's not the open circle. It's not f of g of x. It's f times g of x. So I'm going to take f of x, just an x, put it out in front. And I'm going to multiply that by g of x, which is -4x cubed plus 16x. Okay. Does this factor? Is there something that goes into -4x cubed plus 16x? What is it? We take out a 4. What else? An x. And then I would take out a negative. If you have a negative on the first term, take it out. It's usually going to make your life easier. So I'm going to take out -4x. There's still the x left there that was out in front. And then left inside the parentheses, I'd have an x squared left there. So I took out -4 and 1x. And then I'd have right here, 16x, take out the -4, I'd have a -4 left over. And would you look at that? Another difference of squares, right? X squared minus 4, x minus x squared minus 2 squared. So that's going to factor into x minus 2 times x plus 2. And then it's up to you if you want to combine these x's out in front. You could write that front term as -4x squared. That's how we would have seen it previously. Is everybody tracking so far? We're factoring it, getting it so it looks like what we've been doing the last 2 days. Then we're graphing it. So let's get some x-intercepts here. Sanpreet, can you give me an x-intercept from this? A little louder. 2. Everybody's good with that coming from this guy right there. That's an x-intercept of 2. Now let's get another one. Let's see here. What other colors can I use? Not here today. Wrong class. I keep finding ones that I stuck in the wrong class. There we go. Pressure on. -2. Perfect. And Joey, you know what the last one is? The one you usually forget about, unfortunately. It would be 0. That's exactly right. So this guy right here is going to be an x-intercept of 0. All right, got my 3 x-intercepts. I look back up here. Could even look at the beginning. X times -4x cubed would be -4x to the 4th. Why is that a problem? Yes. So you can think of it a couple different ways. Low, low would be my end behavior. Or, again, I've got 3 x-intercepts and a 4th degree function. That means I'm missing one, which is exactly what Saul said. One of them's a bounce. Which one is it? 0. Does that make sense? That's the squared one. So this one, we're going to bounce off right there. I'm going to start low, come up, bounce off, and back down. You can make it a little bit more exaggerated if you want. You can come up a little bit higher. It's up to you. As long as you're above the x-axis, after that first one, bounce off, and then back below after the third one. How are we doing so far? All right, let's try another one. This is the one that I was mentioning to you at the beginning of class. This is the one that might be new for you. There's a couple terms for what this is. It is pretty much trinomial factoring. You'll also heard it, like I've heard it called wishful thinking factoring. I wish this was a simpler problem, x squared minus 5x plus 4. Does everybody see the relationship between those two? I've just kind of taken the x's down to what I'm used to seeing. So if I had the purple one instead, what would that factor into? What multiplies to make 4 and adds up to negative 5? 4 and 1, right? So normally I would make this x minus 4 and x minus 1. The trick here is that I have extra x's, but it is as simple as making this an x squared and an x squared. Let's check that. Is x squared times x squared x to the 4th? Mm-hmm. And then when I multiply it out, I get a negative 1x squared, a negative 4x squared. Does that give me the negative 5x squared that I need in the middle? And then the negative 4 and negative 1 still get me the positive 4. So while that might be new, you might not have seen one like that before. It's something you've done before without necessarily realizing that it's the same. The only trick here is that instead of x times x, it's x squared and x squared, making x to the 4th. Are we okay with that idea? So that is really just trinomial factoring, but we're not done. What are both of those factors? I'm going to be asking you guys for the name of this because it's going to keep coming up. Not yet. What have I been calling? I said we're going to have a bunch of these. Difference of squares. Those are both difference of squares. Does that make sense to everybody? So I'm going to factor them again. This is x squared minus 4. It's going to factor into x plus 2, x minus 2. This one's x squared minus 1 squared. So an x plus 1 and an x minus 1. Now it's fully factored and I can find my x-intercepts. Is everybody good with them being negative 2, positive 2, negative 1, and positive 1? Any issues finding those? Doing okay, Julian? All right. So I'm going to plot those negative 2, negative 1, positive 1, positive 2. What two things do I still need here? I need the end behavior. And there's one other thing. The y-intercept. Does that make sense to everybody? Where I cross the y-axis. The last two, it was at 0, 0. This one's not. So I'm going to come back up here. And everybody, these two things are actually easier to find from the original one, right? This is my highest degree. And that tells me high end behavior. This is actually going to be my y-intercept. Because if I put in 0, 0 to the 4th power minus 5 times 0, all of that's 0 plus 4. So I'm going to come down here, y-intercept at 4, start up high, down, up, down, up. Make sure we hit right at 4 there. It's close. There's our graph. Are we starting to get the feel for this? Let's do one more, and then I'll have you guys try a couple. So number 4, it's another f times g. So I'm going to do f of x is 2x, so 2x times g of x, 2x to the 4th minus 32x squared. Does this blue one factor? what can I take out of the whole thing? 2x squared. Does that make sense to everybody? So take that 2x squared out. Left inside, I'm going to have just an x squared minus 16. And then I still have this 2x out here. X squared minus 16, yet another difference of squares. Guys, I wasn't joking when I said previously when we were doing the factoring that you'd have pages where you had like difference of square, difference of square, difference of square. Like almost every problem has a difference of squares. The reason for that is it helps keep these kind of small and still have multiple factorings. If they had used trinomials for these, you get these really big things that you've got to work out. So this one, x squared minus 16 is an x minus 4 and an x plus 4. And then I can put these two together if we wanted. 2 times 2 would be 4x cubed. All right, everybody, this is the first time we've had a third degree factor. Does that make sense? At x cubed. Am I going to bounce off of that point? No. Our rule was it had to be even. Does that make sense? Not just multiple, it had to be an even multiplicity. So again, that's why I'm pointing it out right here, because we haven't seen one yet. So if you weren't sure, don't worry about it. Now you know. We're going to go through there. In advanced math, they'd call this a point of inflection. It would do a little like S-curve jog there. It would look kind of like it was changing, but then it wouldn't. It would go back. We don't have to worry about that. Just go through. Does that make sense? As long as you don't bounce off, it'll be fine. So here, I'm going to put in my x-intercepts, 0, which is not a bounce, positive 4 and negative 4. Positive 4 from this one, negative 4 from this one. End behavior, 4x cubed times x is positive 4x to the 5th power. So low, high end behavior. Start low, come up. So I tried to kind of make it, that's what it would really do if you look closely at it. You guys don't need to worry about that. It would like kind of come down quickly and then level off and then go down again. Don't worry about that. You can just go straight through, okay? All right, I want you all to take a look at the homework and do numbers 2 and 5. It's just factoring. Factor it as much as you can. Numbers 2 and 5. We'll go over it. There are some tricky parts on 2 and 5. There's a reason I'm picking those. I want you guys to try those though. We'll go over them in just a minute. Give you 3-4 minutes to do them. All right, so back in the notes, let's come down to the second page. Factor each polynomial, sketch it, labeling x and y intercepts, answer the questions. Okay, so we've got some weird ones here. A subtraction, f minus g. Take f of x, 2x cubed, minus g of x. So minus 8x squared minus 8x. Everybody, do you remember subtracting a set of parentheses? Okay, I have everybody's attention up here. Hi, May, you doing okay? Everybody's good. So I can distribute this negative in and really make this 2x cubed minus 8x squared plus 8x. Is everybody good with that? That negative applies to both of those terms. Now, factor out the common factor, 2x from that whole thing. X squared minus 4x plus 4. And then trinomial factoring, 2x, x minus 2, another x minus 2. Negative 2 times negative 2 makes positive 4. Negative 2 plus negative 2 makes negative 4x in the middle. So that means I have an x-intercept at 0, and then two x-intercepts at 2, or a bounce at 2. So 0, 2, this one's a bounce, odd, positive end behavior, low, high. I already have my y-intercept. It's 0, 0. So I'm going to start low, up, bounce, and up. Okay, how many x-intercepts is that? 2, right? One of them's a bounce, but it still only counts once for x-intercepts. So I have 2 x-intercepts. Okay, relative maximums. Oh, no fair. That was unit 2. Well, we'll hopefully remember it. Relative maximums, increasing to decreasing, right there. At the top of that bump should be a relative maximum. That's the only one for this one. Relative minimums. This bounce right there should be a relative minimum. I'm going down, I bounce off, I go back up. That's a relative minimum. Does that make sense to everybody? Can you identify relative maximums and minimums from that sketch? Next one. All right, I see a negative x squared I can take out of this. X squared plus 6x. And then plus 9. Right, took an x squared out, took a negative out, switched all the signs. This would factor negative x squared, x plus 3, x plus 3. 3 times 3 is 9. 3 plus 3 is 6. And real fast, you guys, if you have issues factoring, it doesn't go away even after this unit. We're doing a ton this unit. There's more next unit. There's more next semester. If you're struggling with factoring, come and talk to me. Go back and watch the videos. Look it up on YouTube. How do I factor polynomials? There's tons of resources out there. You've got to learn it, though. If you didn't learn it last year, we need to learn it now. Here, then, I can rewrite this. Negative x squared, x plus 3 squared makes it a little bit more obvious that I have an x-intercept at 0 that's a bounce, and an x-intercept at, I should put that B on the top, and you'll see why in just a moment. X-intercept at negative 3 that's a bounce. And then my end behavior, looking back up here, negative x to the 4th, that's going to be low, low end behavior. Negative, even. So start low, up, bounce, bounce, down. So number of x-intercepts, 2. Relative maximums. Right? Every time I go up and then down, that's another x-intercept, or that's another relative maximum. So I actually have 2. Both of my x-intercepts are relative maximums. So 2 relative maximums, and then 1 relative minimum somewhere here in the middle. Does that make sense? 1 where I go down to up, decreasing to increasing. 1 relative minimum. Let's see, is there anything special about these last 2? I don't think there is. I think we're actually set. Does anyone have any questions about what we went over there? Do you see anything about 7 or 8 that you really, really want to see worked out? So what I'll do, I want you to start on the homework. The homework is numbers 1 through 14, but you may skip 8 and 11. Those can be extra credit if you want to do those 2. Okay? Get started. The goal here is, again, finish it before Monday. Monday, I will be collecting homework, sections 1 through 4. So I can put those in the grade book, get something in for unit 3 so far. And then Monday, we will be doing a quiz in class, okay? Group quiz, use your notes. But again, the goal is have the homework done on Monday, and then we're gonna practice what we've done so far. Any questions at this point? All right, so I'll do the last 2 examples just silently. I'll kind of write them out up here so that we have it on the recording. But if you guys are good, if you understand it, start on the homework, okay? Start on the homework. I can make that graph. Turn it off, Nikki. This guy's got one maximum. One minimum. Go ahead. Two maximums. One relative minimum.